In ninth grade, we're doing square root functions. This is section 9-1, and it starts on page 551 in your textbook. I'm going to do, today's assignment was page 554, numbers 1 through 13. So I'm going to do actually the even ones. The ones that you were supposed to do for homework are the odd ones. So I'm going to do 2, 4, 6, 8, and 10. And you're supposed to do 1, 3, 5, 7, 9, 11, 13. So when you do square root functions, I posted the notes from earlier that you guys all were supposed to have copied into your notebook. And this is talking about graphing and then comparing to the parent function. Remember, the parent function is y equals the square root of x, so just a basic square root function. So compare it to the parent function graph and then state the domain and range for all of these types of problems. So let's go ahead and start. The only way that you know how to graph functions right now is to plot points. So because I have the x underneath the square root symbol, I want to choose a number that will give me a whole number when I take the square root of it. So I'm going to go ahead and choose 0. 1 will also give me a whole number if I take the square root. And 4 is the next number that will give me a whole number if I take the square root. Because the square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. So these are perfect squares, and that's why I've chosen them, because I want to get a whole number, because whole numbers are easier to graph. So if I do -5 times the square root of 0, my answer will be 0. So that's my first y value. Then -5 times 1 is -5. And then -5 times the square root of 4, which gives me -5 times 2, which is -10. So now I have 3 ordered pairs, and I'm just going to plot them on my graph here. So I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is how many I need on the y. So 0, 0, I'm going to plot my 0, 0 here. 1, -5, and 2, I'm sorry, 4, 1, 2, 3, 4, -10 would be down here. Okay, now it's a curve, so I know that my graph is going to look something like this. And then I'm finished with my graph. So then I need to compare it to the parent function. So this compared to the parent function would be it's a stretch by a factor of 5, because there's a 5 in front of the square root. It's also reflected across the x-axis. So these are the two things that are different about this graph compared to the parent function, which is just regular square root of x. If I were to graph the square root of x here, it would look something like this. So this one is reflected, so that means it opens down instead of up. It is also stretched, so it's a bit wider than the parent function. Okay, so this is your parent function. And this is the one that we have here. Okay, and then the last is state the domain and range. So this one has the same domain and range as the other one, or the parent function. So I would just write the domain is x such that x is greater than or equal to 0. And my range is y such that y is greater than or equal to 0. Because my y, oh, I'm sorry, it's less than. The y is less than. Because the y values go down, the y value range is going to be less than 0. But my x values still go up. So my x value is still greater than or equal to. But this one is less than or equal to. Okay, so that would be number 2. Let's try number 4. Number 4 is the same type. I'm going to make a table so that I can graph it. I'm going to choose perfect squares so that they'll go in here. But because I'm going to be dividing by 2, I'm going to choose perfect squares that will give me something that is divisible by 2. So I'm still going to pick 0. And then I'm going to pick 4. And then I'll pick 16. Because if I take the square root of these, I can divide evenly by 2. So 0, negative 1/2 times the square root of 0 is 0. Negative 1/2 times the square root of 4 is negative 1/2 times 2, which gives me negative 1. And then negative 1/2 times the square root of 16 gives me negative 1/2 times 4, which is negative 2. So my y values are 0, negative 1, and negative 2 for these x values. So I'm going to plot those on my graph. Okay, so I have 0, 0. I have 4, negative 1. And then I have 16, negative 2. So 16, negative 2 is going to be pretty far down there, which means my graph is going to go something like this. It looks like a curve still, but it's a pretty flat curve. Okay, so then I have to say how it's different than the parent function. So if this is my parent function, this one is a compression because it's smaller or more in. So this is a compression of 1/2. It's also a reflection across the x-axis. So this is how it's different than the parent function. And my domain and range are actually going to be the same as the one up here. So my domain is going to be x such that x is greater than or equal to 0. And my range is y such that y is less than or equal to 0. Because again, it opens down. So this one would be negative numbers, which are less than 0. Okay. This third, number 6, is a little bit different. So this one, on these two, they changed the number in front of the square root. And so it was a stretch or a compression, and both of these were flipped or reflected across the x-axis. So they were both opening down while the parent function opens up. This one didn't change the number in front of the x or the square root of x. It changed the number at the end. So this number at the end affects the up and down. So all it's going to do is it's going to take the parent function and shift it down 2 units. But I'm going to go ahead and make myself another table. And I'm going to use perfect squares because I want a perfect square value. So 0, square root of 0 minus 2 is 0 minus 2, so negative 2. The square root of 1 minus 2 is 1 minus 2. So negative 1. And the square root of 4 minus 2 gives me 2 minus 2, which would give me 0. Okay, so here's my ordered pairs. The first one I have 0, negative 2. Which is here. And the second ordered pair is 1, negative 1. Right here. Then you have 4. Oh, I'm sorry. This is 1, negative 1. Then you have 4, 0. 1, 2, 3, 4, 0 is right here. Okay, so here's my graph. It's going to look something like that. It'll go up. So it looks very similar to the parent function. The only difference is it shifted down to negative 2. So this is a translation down 2 units. That's how it's different than the parent function. So here's my parent function. And you see they're similar, it's just one is down. So it's a translation down 2 units. That's the only thing that's different. And then my domain and range, the domain stays the same because I didn't move it left or right. So my domain is x such that x is greater than or equal to 0. But my range went down 2. So now my low point is at -2. So my range is y such that y is greater than or equal to -2. And that's it for that one. This last type, before we get to mixing the two, or the 4 types, is going to be a shift in the x value. So notice that the -3 now is underneath the radical, so that's going to change what it looks like as far as that goes. So again, make a table. And this one is harder to find actual numbers, so I'm just going to pick 0, 1, and 2, and we'll see how it goes. So if I have the square root of 0 minus 3, that gives me the square root of -3. Oh, you can't have the square root of -3, so this one will be no answer. Okay, so let's try 1. Square root of 1 minus 3. This one is also going to give me a negative under the radical, so I can't choose this one. So I have to choose something that's bigger than 3. So none of these that I chose will actually work. So if I pick 3, the square root of 3 minus 3 equals 0. Then let's try 4. The square root of 4 minus 3 equals the square root of 1, so 1. And then if I try 5, it's going to give me a decimal, but let's try it anyway. Square root of 5 minus 3, that's the square root of 2. The square root of 2 will give me 1 point something. Let's check in the calculator. Square root of 2 is 1.41. So I'm going to say 1.4. Okay, and then I'm going to graph. So I have 3, 0, and I have 4, 1, and I have 5, 1.4. So it's going to go something like this. It looks like my general parent function. It is translation 3 units, right? That's how it's different than the parent function. My domain is going to change on this one because the lowest point is at -3. So this is x such that x is greater than or equal to 3. And my range will be y such that y is greater than or equal to 0. Okay, and that's it for that one. I'm not going to do this one because I have no more time left. So, but this one would just mix the two. So make a table, graph, and then it would change compression, and it would shift up 2 units.